So in this expression, A, B, and C are the unknown values. And then your X is the variable or the unknown. So where you have the 0 would also be like the Y, basically. Yeah. It's okay, don't worry about it. Yeah, that's pretty straightforward. So here are some examples of quadratics. 5x squared minus 4x equals 0. X squared plus 5x plus 4 equals 0. X squared minus 1 equals 0. 6x squared plus 22x plus 12 equals 0. And x squared minus 2x plus 1. So does anybody notice something really special about like the two quadratics that are highlighted? You can look at the number of terms. Speak up.
The second term doesn't have that much terms.
Yeah. So like each of them is like missing a term. So in your 5x squared minus 4x, you're missing the c. And the c is still kind of there, but like the c would just be considered 0. That's kind of the same with x squared minus 1. So in x squared minus 1, you're missing your b term. So your b term, sorry, okay, I can do that. So your b term would just be 0. So it'd be like x squared minus 0x minus 1, or like plus 0x. It's just like, it's like a placeholder. Like you can think of it that way. It'll be really helpful later when you're like factoring quadratics or, yeah. Okay, so here's a way to solve quadratics, or like not solve, but like to look at them and like, yeah. So for this example, we're gonna graph the quadratic x squared minus 1. So since the a term is positive, so like the ax squared part, since the a in x squared minus 1 is positive, the quadratic will open up. So you can see on the graph on the right, you can see how like the quadratic kind of opens up like a smiley face, okay? And then if the a term is negative, the quadratic will open down like a frowny face. I hope that kind of makes sense. If not, I can like show you guys on Desmos. Yeah. Okay, so what are the coordinates to the vertex of this quadratic? I hope you guys can see the graph. Someone can just unmute themselves. Do you guys see it? So the vertex is like the maximum point a quadratic can go, or the minimum point a quadratic can go. Does anybody have any idea what it is? Anybody? Yeah. So the vertex is 0, -1. So in our case, since like the quadratic is opening up, the vertex will have to be your minimum. So here our vertex is 0, -1. And looking at the graph, what do you think are our solutions? So our solutions are basically where like the quadratic touches the x-axis. So on the quadratic x squared minus 1, where does the quadratic touch the x-axis? Feel free to type it in the chat.
Wait, what do you mean by where the quadratic touches?
Oh, okay. Yeah, sorry, I didn't really explain it. Okay, so like, do you see where my green line is?
Yeah.
So that's your x-axis. So like basically the rule to figure out what like the solution to your quadratic is basically wherever this like red line, the quadratic itself, touches the x-axis. Does that make more sense?
Yeah.
Yeah. So do you guys see where the solutions are for this quadratic?
Wait, is it where like those pink dots are?
Yeah.
Okay, so the left one is on -1 and the right one is on 1.
Yeah, that's correct. But like most teachers will ask you to give, like, I guess some teachers, like definitely in high school, they ask you to be more specific, but they'll ask for the coordinates.
Oh, okay. So for the right one, it's 1, 0. Wait, no, 1, 0, and then for the left one, it's -1, 0.
Good. Okay, good job. So it's pretty straightforward. It's pretty easy to tell them from a graph, especially if you know what you're looking for. Okay. So yeah, the solutions to the quadratic are called the zeros or the roots. It's nice to know both terms, just so like whenever the question asks you for that answer, you know what they're talking about. And like, as I already said, it's where the quadratic touches the x-axis. So in this graph, it would be where the yellow is like where there's yellow highlight. Okay, so another thing we talk about when we talk about quadratics is that every quadratic has an axis of symmetry. So like, I'm sure you guys all know what symmetry is, right? So it's like something that's like the exact same on both sides. So like a quadratic is the same way, because if you look at the quadratic here, everything that's left to the 0 is like the exact opposite of everything that is right to the 0. So in order to solve the axis of symmetry, by looking at a graph, you can just see like, it's obvious to find like where the line of symmetry is. But if you only have like the equation of the quadratic itself, you can calculate it by taking -b divided by 2a. So does anybody know the axis of symmetry of this quadratic? You can choose not to do it algebraically and just look at the graph.
Wait, can you repeat what you said?
Oh yeah, of course. Sorry. Okay, thank you for telling me. Okay, so the axis of symmetry is the line where the quadratic can evenly reflect across. So do you see how like the quadratic we have on the right, it's perfectly symmetrical?
Yeah.
So basically the axis of symmetry is basically the line where the quadratic can evenly reflect across. It's basically the line where you can like evenly split the quadratic in half. Does that make sense?
Yeah. Is that wait, 5. Is that 5, 5? 5, 5.
I don't think so. Look again. Just be careful.
5,
Remember that.
I mean, my bad. I mean,
go ahead.
0, 5.
Remember that the axis of symmetry is a line, not a coordinate.
Oh, okay. Yeah.
So, okay. Yeah, Sasha is correct. So basically, the axis of symmetry for this quadratic would be x equals 0. So it would be right here. Sorry, my line isn't very straight, but I hope you get the idea. Yeah, so your axis of symmetry will always go through an x, like it will always be an x line. So it will always be x equals something something. So let's also do this algebraically, just to, I want to make sure that you guys get it. So, okay. So let's rewrite the quadratic we have here. So what is our a term? For the quadratic x squared minus 1 equals y.
X squared.
Okay, let's go back. Okay, so remember that like quadratic form was ax squared and then blah, 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 right? So a would be like, x squared is not part of your a. They're like two separate things. So when x squared minus 1 equals y, what is our a term?
One.
Yeah. So it would be 1x squared. What is our b term? Is it 1? Is it 5? Remember that we still have a placeholder right here. So does anybody have any idea? Okay, if not, it's okay. But our b term would just be 0x, right? Because obviously we don't have a 0x term in this quadratic, but the 0x is still a placeholder. And that's really important because we'll use that later on. So plus 0x, and what is our c term? Does anybody know the c term?
-1.
Yeah. So our c term would be negative. Oops, that's about -1. So okay, so let's just say we don't have the graph right here. So we can't just look at the graph to find out what the axis of symmetry is. So we would have to use the formula to find axis of symmetry. So it would be so our formula is negative b divided by 2a. So let's just actually do it algebraically. So what is our negative b? Okay, what is our b term in this quadratic? Okay, I don't know if you guys don't. Sorry, go ahead. Sorry, go ahead.
Is it 0x?
Yeah. So it would be 0 because like -0 still equals to 0. And then what is our a term? It would be 1, right? And that because like our a term is the number that's right in front of our x squared. And obviously, since we don't have anything in front of our x squared, it would just be the implied 1. So 1 times 2 is 2. So our axis of symmetry is 0. We could have kind of just like stopped here when we got the 0 for like our numerator. But yeah, usually it's not so nice because like it's possible to have like axis of symmetries like that are outside of x equals 0. Did everything I just say there make sense? Okay. So, okay, so for these equations, I want you guys to tell me what the vertexes are. It shouldn't be too hard since you're just looking at the graph. Good. So 0, 0 is the first one. What about the second one? Good. So yeah, so the vertex to our second quadratic is 0, -1. And another thing to point out here, does anybody notice anything pretty, like, I don't know, like strange or unique about the second quadratic? Does it have any solutions? Does it cross the x-axis? Yeah, Sasha is correct. So this quadratic does not touch the x-axis. Does anybody? Okay, so remember we talked about how like when a quadratic touches the x-axis, it means that like that coordinate or that point where it crosses is a solution. So what about this quadratic? -x² - 1 = 0. Does this quadratic have a solution? Okay, so both of you are like correct, but then like not correct. But yeah, so this quadratic doesn't have a real solution because it doesn't actually touch the x-axis, which is like, that's where you're correct on, right? But like it has a complex solution. So every quadratic has a solution, but it just may not be real. So when I say like complex, I basically mean that like the solution will involve like a number that includes I. So for those of you who don't know, I equals square root of -1. So the square root of -1 is not possible. Like you can't just get like the square root of -1, but scientists like created that, and that's how we can find the solution of quadratics that don't cross the x-axis, which is why like their solution will include like some form of square root of -1 or some form of I. Okay. If that didn't make sense to you, it's okay, because like it's just something good to know, but you don't have to know that. Okay, so this might be like pretty hard, but like now we're gonna try to write a quadratic equation given some points. So the points that we have are 0, 11, 1, 5, and 2, 3. Does anybody have any idea on how we start, like, to solve this problem? If not, it's okay. Okay, I'm just gonna walk you guys through how to solve it. So first we're gonna plug in the point 0, 11, just to like see, sorry, the chat. Yeah. So we have to like try and plug in points. So here we would plug in the point 0, 11, and then so it would be 11 equals a times 0 squared plus b times 0 plus 11. And then that's how we would get c equals 11. So c is our last term in this quadratic expression. And then now we would plug in 1, 5, given that we already had the c equals 11. So it would be 5 equals a times 1 squared plus b times 1 plus 11. And then simplify, so it would be 5 equals a plus b plus 11. and then -6 equals a plus b. So now we have that. Obviously, we don't have all three terms, a, b, and c. We only have c. So now we have to try the last point. So we would plug in 2, 3. 3 equals a times 2 squared plus b times 2 plus 11. And then 3, we just simplify it. 3 equals to a times 4 plus b times 2 plus 11. And then now we have this other equation, -8 equals 4a plus 2b. So then so like, this is where it would be really helpful if you had gone to last week's class, because like now you know how to like solve systems of equations, and now we just made a system of equations. So we have to take our original equation, -6 equals a plus b, multiply that by 2 so we can get the b's to cancel out, and then we cancel them out, and then 4 equals 2a, and then we have a equals 2. So now, like, through all of these like equations and all the simplifying and plugging in we did, now we have like 2 of the unknown values, a and c. So a equals 2, and then c equals 11. And then now we take the c equals 11, a equals 2, and plug it back in again. And then here you can choose whichever point you want to plug back in. It doesn't really matter, but I just picked 1, 5. And then 2 times 1 plus b times 1 plus 11 equals 5. Simplify, and then b times 1 equals -8. So our final, so b would equal to -8, and then we put everything together to get 2x squared minus 8x plus 11 equals y. Did that kind of make sense? Are any of you guys confused? Does anybody have any questions? Because yeah, I know like I went pretty fast, and I want to make sure you guys kind of get it. Okay, so why does c equal 11? Okay, yeah, that's a good question. Let's go back a bit. So c equals 11 because we plugged in the given point 0, 11. So we plugged in, so 0, 11, for like the coordinate, like how the way the coordinate is written, 0 is an x and then 11 is a y. So that's how we plug it into like the equation. So since 11 is our y, it would be 11 equals a times 0 squared, because it's a times x squared plus bx plus b times 0 plus 11. So that's why c equals to 11. Did that make sense? Does that make more sense? Okay. Okay, good. Does anybody else have questions? Also, a way to like double check your answer is to use Desmos. So I don't know if all of you have used Desmos before, but let's just try it. So what were our points? Oh crap, sorry. They were 0, 11, 0, 11, 1, 5, and 2, 3. And then our final answer was 2x squared minus 8x. So I hope you guys can see all 3 points. Here, I'll just label them. So obviously you can see that how the 3 points that we were given map perfectly onto the quadratic we wrote. So that's how you can double check your answer. You can also do this on a graphing calculator like a TI-84, but it's kind of hard to like read it, especially if you don't have like a CE version. So Desmos is always like a helpful tool to check your answer. Okay, let's keep going. Okay. So now we're going to look at the quadratic formula. So the quadratic formula is basically a rewritten version of the quadratic like standard form, but like you can derive one from the other. So you can get this like entire mess, the negative b plus or minus square root of b squared minus 4ac all divided by 2a. You can get this like formula from the standard form. You can derive it, but it's really time consuming and you don't really need to know that. So just like memorize quadratic formula. It's going to become really useful later down the road if you just have it in your head. So this formula will always work when you're solving a quadratic, but it's like really time consuming, especially when you get like lots of big numbers or like really long decimals. So like it's really nice to know, but it's not as helpful if you don't have a calculator. Okay, let's move on. So now we're going to use the quadratic formula to solve a quadratic. So remember that a solution to a quadratic is wherever the quadratic itself touches the x-axis. So it's where your zeros or roots are. Does everybody have like a paper and pencil next to them right now? Because if not, we can like solve together. But I'd like for you guys to try it on your own. Okay, so go ahead and try it. I'll give you a couple minutes to first just start it. But if you need help, you can chat with me, or yeah. If you don't figure it out, it's okay too. Okay, I hope that was enough time for you guys to at least try doing it, like with the quadratic. So in order to solve this, we would just find the a, b, and c from the given x squared minus 1 equals 0, and then plug it in. Wait, okay, never mind, it's fine. Okay, so like it's plugged in right here. So yeah, you just have to plug in everything. And yeah, I hope it was pretty straightforward. I wasn't sure. You guys might have been able to just seen like how it was plugged in. Like I might have just shown it on the screen, but yeah. So your final like your terms should be -1, 0, and -1, and then that's weird. And then just like plug everything in. Did that make sense? I can go like in more detail. sorry, go ahead.
Yes.
Okay. So I think I like talked about how like if you use like the quadratic formula, it's a little time consuming sometimes. So some other ways you can solve it include cross method. So cross method is a method of factoring quadratic trinomials. It's also kind of important to remember that not all quadratics are factorable, and to solve factorable quadratics, the cross method is one of the easier ways to do it. Just like a disclaimer, you don't have to use a quadratic to solve a quadratic formula, like to solve a quadratic, sorry. But like, I think it's nice to know this one, but if you don't immediately get it, it's okay, because like there's other methods and you can always graph it or something. So today we're gonna factor the quadratic x squared plus 9x plus 14. So in order to factor it, like you try to split it up into two groups. So it's like x plus blank and then multiplied by x plus blank. So what are the factors of x squared? So what multiplied by what gives you x squared? It would be x, right? Because you multiply x times x and then you have x squared. Okay, so we would write it like across. So like you have the x and then the x and then the cross and then the zw. So our zw is like the blank from the x plus blank and then x plus blank. It would be like x plus z times x plus w. And then, so zx, like, let me find the pen thing. Okay, so z times x must equal to 9x. Must equal to 9x. Sorry, zx plus wx must equal to 9x. Zx times, yeah. And then z plus w must equal to 9 because of what we got here. Does that make sense, or should I go in depth with that? Does everybody understand how I got the zx plus wx must equal to 9x?
Yes.
Okay, okay, good. So knowing that, z times w must also equal to 14. So 14 is where we got the c term of x squared plus 9x plus 14. So basically, the big question that we have to answer is, what are the factors of 14 that add up to 9? So like z times w must equal to 14, and z plus w must equal to 9. That's like the big question. So can anybody think of any factors that, okay. Can anybody think of any factors?
7 and 2.
Yeah. So it would be 7 and 2.
7 times 2 is 14, and 7 plus 2 is 9.
Good job. So our factors, like I already said, the factors of x squared are x times x. Yeah, so our factors of x squared are x times x, and that like he said, the factors of 14 are 1 times 14 and 2 times 7, but 2 times 7, because 2 plus 7 equals 9, so then those would be our cross method, like our final cross method, because 7 times x plus 2 times x equals 9x. And then 7 times 2 equals 14. Does that make sense, everybody? Okay, sounds good. So I hope you guys can kind of see how like quadratic formula would be really messy here, because like, okay, so like quadratic formula is like negative b and then blah, 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 right? But then you have to do all that square root stuff and division. And I think it's just like much easier to just like know your multiplication tables and just like know that 2 times 7, just like, yeah, it's just like faster, especially, and you don't really need to do as much work. And like, yeah, it also minimizes your chance of making mistakes. So now we're going to look at vertex form. So vertex form is a times x minus h squared plus k equals y. So what's really unique about vertex form is that it's centered around one point. So you can only write vertex form if you know the vertex of the quadratic or the parabola. This is also another equation to just memorize. It's really nice to have it in your head instead of just like not knowing it at all. So yeah, so for all the stuff I've said that like you should memorize, you don't like have to memorize it before next class, because like chances are you probably won't need to for next class, but it's just like, these are just things that you should know like down the road or like soon, especially if you're going into like high school or like 8th grade next year. So you can also derive standard form, the ax squared plus bx plus c, to vertex form. So the a in standard form is equal to the a that they write in vertex form. That's just something nice to know. And if the a is positive in both cases, the quadratic will point up. If the a is negative in both cases, the quadratic will point down. And then, so does everybody see the hk in vertex form? Okay, I hope you guys can see it. So the hk is basically the quadratic. Sorry, not the quadratic, the vertex of the quadratic. So yeah. So if you're gonna try to find the vertex of a quadratic, which form would it be easier to find it from? The vertex form or the standard form? Which one is, like, which one makes it more obvious to find the vertex? It would be the vertex form, right? Because for the vertex form, you don't even need to do any calculations or to graph it because it's just there, like in the form itself. Yeah. Good. So also, I'm not sure if I mentioned this, but you can also like convert between standard form and vertex form. Like if you have one equation, you can convert from both, but that's kind of complicated and I don't think you guys need to know that. Like I never needed to know that. So yeah. So now we're gonna look at what is in a quadratic that is in vertex form. So since the vertex of this quadratic is graphed, so all we have to do is plug in the vertex to try to find the vertex equation. So it's pretty straightforward because we have the hk equals 1, 3, so h equals 1, and then k equals 3. So it would be a and then x minus h, so x minus 1 squared plus k, so it's like plus 3 equals y. So like after this, all we have to do is like find out what a is. So the easiest way to do that is to just plug in a point. So remember how like we plugged in points to find the equation of quadratic? That's basically what you have to do here again. So you plug that in, so we're trying to find a, right? So it would be 0 minus 1 squared plus 3 equals 5. Simplify, and then we get a equals 2. Does anybody, okay, and then like after this, we just plug back, like put everything together and then we get vertex form. Does anybody have any questions? So another thing you can do with quadratics is to do word problems with Does everybody feel comfortable with quadratics? Because I don't want to move on to word problems if you don't really understand how they work. Does everybody feel comfortable with quadratics? It's okay if you're not, because I can always go back and review some things. Okay. Do I have? Okay. I have the answer written on the page. Okay. So so I know the answer is like literally on like the screen, but does anybody have any idea on how we'd solve this? Okay, I'll just like read it out to you guys. Elaine throws a stone off a bridge into a river below. The stone's height in meters above the water, x seconds after Elaine threw it, is modeled by this equation, hx, negative 5x squared plus 10x plus 15. How many seconds after being thrown will the stone hit the water? So do you guys want to solve this by factoring or like cross method or quadratic formula? How do you guys want to solve this? Okay, like I know it doesn't really matter, but like one way is gonna save time and the other way is gonna like waste time. Okay, so I think the easiest way to solve this is to just first factor out the 5. So, because like the A, B, and C in this quadratic are all divisible by 5. So let's take out the negative 5 just for kicks and see what happens. So it would be negative 5 times parentheses x squared minus 2x, and then minus okay, so now we can just like kind of ignore the negative 5. So is x squared minus 2x minus 3 like factorable using cross method? If so, what are the factors? What times what multiplied gives you negative 3, but added together gives you negative 2? Okay, let's just factor negative 3 then. So negative 3 equals 2. Negative 3 times what? It's not that bad. It's not that hard.
1.
Yeah. So it's 1. What is negative 3 plus 1?
Negative 2.
Good. So that's how you find your factors. Yeah, it's the more you keep on doing these like quadratics, the more faster you get at finding the factors. So I know like this is pretty new to most of you guys, but it gets a little easier. So we have negative 5. Sorry, I'll just like write it out. Okay. So you have your x here, and then here's your another x. Our cross, so it would be negative 3 and 1. And then now you just write it across. So our final, like, our factored form with this quadratic would be -5 times x plus 1 times x minus 3. So what do you guys think, just looking at like that factored out form, what do you guys think the solutions are? Just like ignore the word problem. What are the solutions? Remember, we have to set everything to 0. I don't think I like actually talked about this, but like x plus 1 has to equal to 0, right? In order for this to work. So if x plus 1 equals 0, what is x? Oops. If x plus 1 equals 0, what is x?
Negative.
Good, yeah. It's -1. If x minus 3 equals 0, what would be x?
3. Yeah.
Good job, guys. Okay, so the two numbers we got for our solutions are -1 and 3. But now let's read what the question is actually asking for. How many seconds after being thrown will the stone hit the water? So can like the number of seconds be negative?
No.
Yeah, you're right. So then obviously we have to rule out -1 because even though it works in this quadratic, it doesn't actually like match like the world life situation because obviously time can't be negative. So that's why 3 must be our answer. 3 seconds has to be our answer because 3 is like it's like the only other number that satisfies this quadratic that also satisfies the question itself. Does that make sense?
Yes.
Okay, good. Let's move on. So you can see how like I graphed out the entire quadratic. So you can see how like even in the graph, we can see that one of the numbers is negative. Like one of the answers we got was negative. And like even though it worked for the quadratic, even though it's still technically a solution to the quadratic, it doesn't actually work for the problem because time can't be negative. So even if you just graphed it, you can see that the answer is 3 seconds because one of the solutions to the quadratic is 3, 0. So here's another one where you can already see the answer before I actually do it for you guys. But let's just try this problem for fun. So a certain company's main source of income is selling cloth bracelets. The company's annual profit in thousands of dollars as a function of the price of the bracelet in dollars is modeled by Px equals to -2x squared plus 16x minus 24. So for this question, should we graph it out or should, not graph it out. Should we factor it or should we try and do quadratic formula? Which way would be faster? Yeah, factoring. I know I said that like not all quadratics are factorable, but usually for word problems, people will give you like a factorable quadratic just to make it easier on you. So let's just factor out the -2. So -2 factored out, that would give you parentheses x squared minus 8x plus 12. So is this, okay, so let's go back. So, okay, so what are the factors? So like what times what multiplied gives you 12, but added together equals -8. So 12, okay, so 12 is a factor of -2 and what?
6.
You're correct, but like we're trying to find positive 12 right here. I don't know if you guys know like the rules of
Oh yeah,
multiplying.
yeah, -6. Sorry.
Yeah, that's correct. -6. Because -2 plus -6 gives you -8, and -2 times -6 equals 12, positive 12. Okay, so then now that we know that, let's just write out our cross method. And -6. Okay. What? Is something wrong? Okay, so you can see, okay, so circled in red are basically like the groupings that we have. So it would be x minus 6 times x minus 2, and that would give us like solutions, right? But like right now we're not trying to find the solutions because we're trying to find the maximum. I kind of led you guys like in the wrong direction, but yeah, this is basically how you would try to find it if you're trying to find the solution to this problem. But okay, so the question actually asks, what bracelet price should the company set to earn the maximum profit? So if we were to graph this quadratic, where would the maximum profit be? Would it be a vertex? Would it be a solution, or? So a maximum profit would be like the highest point on the quadratic. Does that make sense? So the maximum point would be the highest point of quadratic. So we're basically, the question is basically asking us to find the maximum, like the vertex, basically the vertex. So in order to solve this, I know we're going a little over time. So we would find the axis of symmetry. So basically, this line right here, and it would be right here. Does that make sense? Okay, so then here, I'll just like clear everything. Okay, so axis of symmetry is -b over 2a, right? What is the b in this equation? You can put it in the chat or just like say it out loud. Okay. Yeah, so it would be -16 and then 2 times our a. What is our a? It would be -2, right? So what is -2 times -2? Oh, sorry, 2 times -2.
-4.
Good. So -16 divided by -4 would give you 4. So that's where you get the 4 from. So I know I talked a little bit about how like at first I was trying to find like the solutions, but like the solution here would not actually be the answer to this question because the solution would be where the company's annual profit is actually 0, if that makes sense. Okay, so like for this equation, you could also graph it and just try to find the vertex through graphing or like just through Desmos, like I already showed you guys. If you do have access to a calculator, it's like really easy to find the answers to these questions, or like this type of question. So yeah. Okay, so I know we're a little over time. So let's recap our lesson. So today we learned about quadratics and vertex form. There are 3 ways to solve quadratics. You can graph them, you can use a quadratic formula, or you can factor them. And then we wrote a vertex form. We learned how to write a vertex form and then write equations based on given points. And we also learned how to graph them and use word problems. So does anybody have any last minute questions before class is over? If not, that's okay. I'm really glad that some of you guys participated this class, and I'm not sure what next class is on, but I don't think I'll be teaching next class. Make sure to do your homework, or like just try to if you can. It should be pretty quick. It should be up. It also should be up on Google Classroom along with the slides that we did this week, and a recording of the session will be in Google Classroom if you need it, or if you need to go back and look at what we talked about today. I think that's everything. Good.